Cool. All right. So we're going to be doing a few problems on the homework and that interest compound. So problem 6 in the homework, so we're going to start on problem 6 in the homework. It's asking us to find the 18th term of the sequence. To figure out the 18th term of the sequence, the first thing we need to do is figure out, what's R actually going to be. So I can see that I go from 4 to A, then to 4 to negative 4. So I know that if I take 4 and I multiply it with R twice, or R squared, I get 4 cube root of 4. So to solve for R, I'm just going to isolate it. So I can divide by 4 on both sides. I get that R squared equals the cube root of 4. Then I can take the square root of both sides, or I can say I raise it to the 1/2. So R, because 2 times 1/2 is just 1, equals 4 to the 1/3. I can rewrite as 2 squared divided by 3. It's the same exact thing. To the 1/2. When you distribute the 1/2 in, or you do 2/3 times 1/2, these 2's cancel out. And what I'm left with is R equals 2 to the 1/3, or the cube root of 2. So that's what R is going to be. R is the cube root of 2. And to figure out the 18th term, what I'm going to do is I'm going to make an explicit formula. Because when I have the explicit formula, finding something way down the line is a lot easier than maybe find a recursive formula and trying to go step by step by step. So f of n, that's going to equal any term here we want. So we can go like the 4. So 4 times my R value of the cube root of 2 raised to the n minus 1, because that 4 is f of 1. So if I want to figure out what f of 16 is, that's 4 times the cube root of 2 raised to the 15th power, or that's 4 times 2 to the 1/3 to the 15th power. It's the same thing. Distribute this 15 in, we get that 4 times 2 to the 5th. 16 over 1, 4. This right? R squared, yeah. And we wanted the 18th term. I'm sorry. So let's back up. Just looking wrong. We want the 18th term. So we're gonna back up real quick and go back here. We want the 18th term, not the 16th. So 18 minus 1, that's 17. So we have 4 times 2 to the 1/3 times 17, which we can say is 4 times 2 to the 17 over 3. I don't ever want an exponent like that. I'm going to reduce it. And that's the same thing as saying 4 times 2 to the 17 over 3 is the same as 2 to the 5th times 2 to the 2/3. Right, 3 goes into 17 5 times with a remainder of 2. So it's 2 to the 5th times 2 to the 3rd. So 2 to the 5th, that's 32. 32 times 4, when I distribute this in. So 32 times 4 is 128. So I have 128 from multiplying the 4 and the 2 to the 5th times 2 to the 2/3. That's the same as the 3rd root of 2 squared, which is 4. So that's your final answer. So the process here, figure out your R first, your whatever it's called, your R value, and go and put it into explicit form, and then from the explicit form, plug in 18 and solve it from there. Any questions about that? Are we good? All right, let's keep going. Number 15, given f of n is a geometric sequence where f of 3 equals 32 and f of 9 equals 72, find f of 16. So I know this is a geometric sequence, and I need to figure out, well, what's my what's f of 16 here. So for this, I'm gonna figure out what my R value is first. So I go from f of 3 to f of 9. So I'm going 6 terms, and I go from 32 to 72. So what that's saying is that to go from f of 3 to f of 9, I'm going 9 terms. So I'm going to multiply that 32. Sorry, not 9 terms, but 6 terms. I'm going to multiply that 32 with r to the 6th. And that ends up giving me 72. All right. So I just solve for r here, divide by 2, or divide by 32, sorry. I get r to the 6 equals 72 over 36, which reduces down to, I think they're both divisible by 4. Yeah, so we get 18 all over 9. That's 32, not 36, sorry. So 72 over 32, and that's 18 over, divide by 4, that's 8. Divide by 2 this time to give me 9 over 4. So r to the 6th equals 9 over 4. Or I can rewrite this 9 over 4 as 3 squared over 2 squared. And the reason I'm doing that is because when I take both, I can rewrite this 3 squared over 2 squared as 3 over 2 all squared. So r to the 6th equals 3 over 2 all squared. Take the 6th root of all this, and you get that r equals 3 over 2 to the 1/3. Everyone with me so far? Are we good? So a lot of times the hard part of these problems is finding the r, and we're not really done yet because this r is the same thing as saying it's the 3rd root of 3 all over the 3rd root of 2, and I need to rationalize it. I don't ever want a fraction exponent or a radical in the bottom. So I'm gonna multiply the top and bottom by what I need to complete this radical to get rid of it. So I have 1, 2 inside that radical. That's why I'm multiplying top and bottom by 2 more 2's of that same radical. Tanish, go ahead.
Can you please scroll up? So how can you say that 32 times r to the 6th is equal to 72? Like, wouldn't r to the 6th be equal to 72 over? Oh, yeah, wouldn't r to the 6th be 72 over 32?
That's what I have right here.
Oh,
because r takes you from one term to the next. So r will take you from f of 3 to f of 4. R squared takes you from f of 3 to f of 5, and you keep going that way. Because r takes you from one term to a term right afterwards. So what I'm saying is when I take f of 3.
Oh, right, you multiply 32 by the thing 6 times to get 72. Yeah.
Over from f of 3 you get to f of 9. Because 3 plus 6 is 9.
Okay, thank you. I just had a...
All right. And now from here, I'm going to finish off this part right here. So the bottom, the cube root of 2 times the cube root of 2 squared, the cubes really just cancel out there. So we're left with a 2 on the bottom. And on the top, I'm left with 3 times 4, which is the cube root of 12. So r is the cube root of 12 all over 2. That was a lot of work for r, but let me show you how I saw on the quiz. Sometimes you just get an ugly r, and it does take a lot of work to get it. All right. So from here, I need to figure out, well, what's f of 16? Well, since I have my r value and I want something kind of way down the line, it's probably gonna be my best bet to just make an explicit formula. So I'm gonna go ahead and just say, well, f of n, that's gonna equal one of my terms right here. So either 32 or 72, it doesn't really matter which one. I'm just gonna go with 72. Times my r value, which is the cube root of 12 all over 2, raised to the n minus whatever term this is. 72 was the 9th term, so it's n minus 9. That's my explicit form. And I want to know what's happening at the 16th term. So I have f of 16 is going to equal 72 multiplied by the 12th, the third root of 12 over 2, all raised to 16 minus 9, which is 7. All right. And then from here, I'm just going to work it out. I get 72 times, well, 12 I can rewrite actually as, or the cube root of 12 I can rewrite as 12 to the 1/3 all over 2 to the 7th power. And I'm doing that because I can distribute this in and I can deal with that exponent a little better. So from here, once you distribute that out, you have 72 times 12 to the 7 over 3 all over 2 to the 7. And this part right here, you honestly could plug this to a calculator and reduce it down if you really wanted to. But you also could just find its prime factorization. The prime factorization of 72, that's 9 and 8, which is 3 squared and 2 cubed. And 12 to the 7 over 3, I don't ever want a mixed fraction like that. So I can rewrite that as 12 squared because 3 goes into 7 2 times with 1 left over. So I'm pulling out all the total groups so I can reduce it down to have a regular fraction as its exponent. All over 2 to the 7. And like I said before, same thing. This whole part right here, you could plug into a calculator and simplify it down that way, but you also could do it with prime factorization. So here, just 2 to the 3rd and 2 to the 7. These reduce down, leave you with just a 2 to the 4th on the bottom. So I have 3 squared times 12 squared all over 2 to the 4th times 12 to the 1/3. So you have 9 times 144. This part I'm just going to put into the calculator. I'm not going to worry with that about that. So I have 9 times 144. That's 1296 times the cube root of 12 all over 2 to the 4th. That's 16. So you divide 1296 by 16. In this case, you get an even number. So we end up getting 81 times the cube root of 12. So that's how I would have done that problem. But I do want to say that sometimes when you get to this last part right here, it won't always like divide down really nicely. Like let's say you have 1296 over 16. It won't always just divide nicely, give you a whole number. Sometimes it just becomes a reduced fraction. You have to pay attention to that. So you still need to see, how can I reduce this? Because the calculators we give you guys, they don't reduce fractions for you. It'll just kind of tell you the answer. So sometimes you're just gonna have to take this. Let's say it was like 1296 over 18. You'd have to divide them both by 2 or whatever it is to reduce it down as much as you can. Does that make sense what I'm saying? Any questions about this problem? Alden, go ahead.
I kind of came in the middle of this. I didn't realize the Zoom tutorial was starting at 1. And so I'm wondering, is there a test review that we can download online and print out, or were we supposed to get one on Friday?
The test is Tuesday, so we're giving you the test review tomorrow. So nothing's been uploaded yet. But I'm not going off the test review for that reason. I'm going off the homework and the interest thing we gave you on Friday.
Oh, I thought I read somewhere. I thought I read somewhere it was test review. I was very confused. Okay,
Oh,
never mind then.
Yeah, on the tutorial schedule thing, it says test review, but that's just kind of like my own test review where I kind of just, like this is Zoom test review where I have my own set of problems to solve. That's
all right. Okay, never mind.
Great.
Yeah.
Any questions here about this problem? Are we good? Great. All right, number 21 on the homework. On this one, I'm asking you guys circle all the following that represent an exponential growth. So exponential growth means your b is greater than 1. So I'm gonna look at all these and make sure they're in the right form, because remember, I don't want a negative exponent, and I always want the exponent to be in the form x minus h, or even b times x minus h. That's okay too. But really the most important thing here is that you do not have a negative exponent. So for number one, I have 7 times 1.04 to negative 2/6. So in this case, my b is greater than 1, but I have a negative exponent. So I need to fix that. And when you do, we end up getting 7 times 1 all over 1.04 to the 2x. Because a negative exponent means you flip it. In this case, I get, what's it called? I get 1 over 1.04, that's going to be less than 1. So that's why 1 doesn't work. We'll go on to number 2. I have 4 over 7 to the negative x. So I don't want that negative exponent. So what I'm going to do is I'm going to rewrite this as 4 times 1 over 7 to the negative x, which is the same thing as 4 times 1 over 7 all raised to the negative x. I don't want that negative, so I'm going to rewrite it. I can rewrite it as 4 times 7 to the x. A negative, you get rid of it and you flip what's inside of it. So this 7 is what my actual base is. That's greater than 1. So that tells me that 2 is going to be an exponential growth. Now for number 3, I have 5 times 3 over 2 to the 1 minus x. Well, I don't ever write it in that way, so I can just rearrange it as 5 times 3 over 2 to the negative x plus 1. I factor out a negative to get 5 times 3 over 2 times negative of x minus 1. Then flip it to get rid of that negative in the exponent. 5 times 2/3 to the x minus 1. 2/3 is less than 1. So that's why this is not an exponential growth. It's an exponential decay. Tanish, go ahead.
For number 2, for like the second step, you had like 1 over 7, 1 over 1 over to the 7 to the negative x. But how do you apply it to the entire fraction if the negative x is only applying to the 7 and not to the 1?
Well,
Like, don't
that's why I took the 4 out to the front, because 1 raised to any power is always 1. So 1 raised to square, 1 squared, 1 to the 3rd, 1 to the 4th, 1 raised to the x power. 1 raised to any number is always going to be 1. Like 1 raised to negative 2 powers, 1 over 1 squared, which still ends up being 1. So if you 1 to the x is the same thing as 1, because 1 raised to any power is always 1.
like okay, even like fractions and negatives and everything.
Yeah, because what I'm saying is 1 over 7 to the negative x. This is the same thing as 1 over 7 to the negative x. Because if I took this negative x and I distributed it in, I get 1 to the negative x over 7 to the negative x. But 1 raised to any power is always going to be 1. So
Okay.
1 raised to the x is kind of redundant. It's like saying 1 times 2 when you try to answer it. Doesn't make, why even say 1 times 2? You just say 2.
Okay. I'm sorry. It was dumb.
Do you get that? Does it make sense?
Yeah, it makes sense now.
All right, let's go on to number 4. 3 to the ex, well, that's just the same thing as saying 3 times 1 over e to the x, which is the same thing as saying 3 times 1 over e to the x power. And the same reason we said before, 1 raised to x is going to be 1, so you can pull out an exponent of x out of 1 because it's not really doing anything. So that's going to be an exponential decay, since 1 divided by e, where e is about 2.7, is going to give you a number less than 1. So that's why 4 is an exponential decay. It's not a growth. All right, now for number 5. 4 over 9 times 2 minus x. So same thing we did with number 3. I'm going to rewrite the exponent as negative x plus 2. Then factor out the negative to get negative of x minus 2. And then finally take that negative and flip the base to get 9 over 4 x minus 2. So 9 over 4 is greater than 1. So that tells you that 5 is going to be an exponential growth. And then finally, number 6. 3 over 16 times 4 over 3x. I don't even have to do anything here. You just kind of set up for me. This 3/16, that's just your a value. I don't care for that. But this base, what's being raised to a power of x, is 4/3, which is greater than 1. So right away, I don't have to do any work. I can see right away that that is going to be an exponential growth. Go ahead, Tanish.
How come for number 5 you didn't like turn the fraction into 4 times 1/9?
Like you mean like I did with number 4 and number 2?
Yeah.
Because x is on the outside. For number 2, the x is on the bottom. I don't ever want my variable of x of an exponent of x to be on the bottom. So that's why I work to get it out and put it as a base all raised to the power of x. I don't want it as like some number over 7 to the x, something like that. I don't want that. So I want to take it. But
Okay.
on number 5, x is a base 4/9. That's fine. But the exponent is already raised to the whole base.
Okay, got it. Thank you.
Great. All right, Sophia, go ahead.
For number 4, how is 1 over e to the x the same thing as 1 over e all over, or all to the x power?
So because 1 raised to the x power is the same thing as 1. So when I have 1 over e, or 1 over e to the x, that's the same thing as 1 over x over e to the x, right? Because 1 to the x is the same thing as 1, right? It's the same
Yeah.
thing. So from here, I can pull out an x and get that.
Okay. I get that.
Make sense?
Yeah, thank you.
Great. Any other questions here? Are we good? All right, let's keep going. Number 23. Sir, which of the following is equivalent to translating the graph to the left 4 units? Okay. So I have this graph right here, this -2 to the x plus 1, and I want to translate it 4 to the left. So anytime you're translating something 4 to the left, that means you're adding something to your exponent of x. So if I have -2 to the x plus 1, and I'm going to the left 4 units, that means I'm going to be adding 4. All right. And I want to know, well, what's the same thing as adding 4 to this equation? So what that means is I'm going to keep this -2 to the x plus 1. I don't want to mess with it. I want to leave it alone. Instead, I'm going to get rid of that 4. So this is the same thing as saying, well, I can times, sorry, not that negative should be outside the box. I can multiply this with a 2 to the 4 because these have the same base. So I can add the exponent. So you get 2 to the x plus 1 plus 4, which is what I have here. 2 to the x plus 1 plus 4. So 2 to the 4, that is 16. So what I'm doing is I'm multiplying the whole equation by 16, or in other words, I have an a value of 16, which means I'm vertically stretching the graph by 16. Does that make sense? Are we okay with that? All right, then let's keep going. 24, write the function that is the result of vertically stretching the graph f of x by a factor of 2 before translating it 7 units to the right and 3 units up. All right, so let's go step by step. So I have 3 to the x plus 4. And I'm going to vertically stretch it by 2. So vertical stretch by 2 means I'm going to take my a value, multiply by 2, and multiply the k value by 2 as well. But I don't really have a k value to multiply with. So I'm just going to multiply 3 to the x plus 4 by 2. So I have 2 multiplied by 3 to the x plus 4. After that, I'm going to take this and translate it 7 units to the right. So I'm going to go to the right 7. So what I have is 2 to the 3 to the x plus 4. I'm going to the right 7. So I subtract 7. Subtract h, where h is 7, so minus 7. So what I end up getting is 2 times 3 to the x minus 3, then 3 units up. So we're going to go up 3. So I have 2 to the 3 to the x minus 3, and then I add 3 to it. And that's going to be my final answer. 2 times 3 to the x minus 3, all plus 3. And we'll call this g of x. Any questions about that? Okay, if not, let's keep going. With Fatima, raising your hand, or is that the clapping emoji? I'm not sure. Raise your hand. Okay, what's up? What's how can I help you?
So why did, for this problem, you added, oh, well, subtracted 4 minus 7 for moving right 7 units?
That's because you know, x's always work a little weird. Remember, it's like 3 to the x minus h, right? So if I'm going to the right 7, that tells me h is 7, right? So if I have 3 to the x plus 4, when I put an h value in, I'm putting it as always subtracted by 7. So when h is 7, I plug that in. I say, well, 3 to the x plus 4 minus this h value 7. I don't know if that answers your question, but it's kind of how the x's work. It's always x minus h. So if we kind of think of it as, well, x plus 4, and I'm minusing h to it, I'm moving at all of x plus 4 by h. So it's minus h, where h is a positive 7 because it's going to the right 7.
Yeah, but for number 23, like how you, for the left 4 units, you kind of like distributed it or something and made it a.
Oh, for this one?
Yeah.
Just back up this one then. So this is what I originally have, right? X plus 1, right? And I'm going to the left 4. So that tells me I have an h of negative 4, right? That's my h. So I'm going to take this x plus 1, and I'm going to subtract h to it, where h is negative 4. So what I get is negative 2 to the x plus 1 minus negative 4, which is a positive 4. But because I want to know, well, what's happening to the graph negative 2 to the x plus 1 when we add 4 to the exponent. So I can just take this plus 4, because anytime you're adding 4 to the exponent, that's the same thing as multiplying with the same base by the number you added. That's why it's a positive 4 here. Does that make sense?
So like, could you also write it as like negative 2 to the power of x plus 5?
Yeah, it's the same exact thing. These are the exact same thing.
Okay.
That's what this problem is asking. It's just because it's asking, well, what's the same as moving this graph to the left 4? Well, the same thing as moving this graph to the left 4 is the same as stretching it by 16.
Okay.
So I was kind of showing, well, I can go from plus 4 to 2 times to the 4th, and all of a sudden it's a different transformation that makes the graph the same.
Oh, I see. Okay, thanks.
No problem. All right, back to 24. Any questions here? Are we okay? Okay, then let's keep going. All right, write an exponential function whose graph passes through the points 4, negative 4, 6, 2, and 8, 26. We are on number 34. So this is one of those problems where I want to solve for the exponential function f of x equals a times some b to the x power, all plus k. So I need to solve for a, b, and k, 3 unknowns, and that's why I'm given 3 equations, because I need to solve for all 3. If you have 3 unknowns, you need 3 equations. All right. So the first equation I'm going to make is when I plug, I guess, 4, negative 4 into it. So that's going to be negative 4 equals a times b to the 4th plus some k value. Equation 2 is 6, 2, so it's 2 equals a times b to the 6 plus k. Equation 3 is 26 equals a times b to the 8th, all plus some k value. So that's what I have. And I have these three equations, and I want to kind of get rid of a variable each time I do something with them. So the first thing I'm gonna look to get rid of are these k's, because I'm adding something to it. I can get rid of those pretty easily by just subtracting them. So I can take equation 2, subtract it with equation 1. So I have 2 equals ab to the 6 plus k. That's equation 2. Subtract that with equation 4, which is negative 4 equals ab to the 4th plus k. So 2 minus negative 4, that becomes 2 plus positive 4, that's 6. ab to the 6 minus ab to the 4th, you can't really do anything there. So we just have to write it like this. And then k minus k is 0. So this is what I'll call equation 3, or equation 4, sorry. But I'm gonna see if I can factor something out here. And I can factor out an ab to the 4th. And what I'm left with is ab, or not ab, sorry. Just a b squared minus 1. And this is what I would call equation 4. And then I'm going to take, I guess, equation 3 and subtract that with equation 2. So equation 3, that is 26 equals ab to the 8th plus k. Equation 2 is 2 equals ab to the 6th plus k. I'll subtract these from each other. 26 minus 2 is 24. ab to the 8 minus ab to the 6 is ab to the 8 minus ab to the 6, and the k's cancel out. So same thing as before. I'm going to see if I can factor something out of this ab to the 8 minus ab to the 6. So what I get is that 24 will equal, well, I can factor on ab to the 6 and be left with b squared minus 1 as well. And this is what I'll call equation 5. Everyone with me so far? All right. And then from here, I'm just going to divide them. So I can do equation 5 divided by equation 4. Equation 5 is 24 equals ab to the 6 times b squared minus 1 all over 6 equals ab to the 4th times b squared minus 1 as well. So I can see right away these b squared minus 1s cancel out, and this is going to reduce to a 4 on top. So just rewrite it really quickly, make it a little nicer. So I have 24 divided by 6, that's just 4. That's going to equal ab to the 6 over ab to the 4. And these b squared minus 1s canceled out. Well, then from here, the a's cancel out. This b to the 4th goes away, and I'm left with a square on the top. So I'm left with 4 equals b squared, or that b equals positive 2. And it's only going to be positive 2, and that's because it can only be what's it called? The positive base can only be positive. You don't want a negative base, so your b can only be positive. So that's why we're not putting a plus or minus. It'll just be positive 2. So anyway, you have your b equals 2, and we're going to go ahead and plug it into one of the two previous equations. It doesn't matter which one. I guess I'll go with equation 4. So I'll plug in b equals 2 into here. So I get 6 equals a times 2 to the 4. I'm going the wrong way. 2 to the 4 times 2 squared, which is 4 minus 1. So 6 equals 2 to the 4 is 16. So 16a times 3. I can divide 3 over and get that 2 equals 16, 16a, or a equals 2 divided by 16, or 1/8. So a is 1 over 8. So I have my a, I have my b. I can go back and plug it into one of the first 3 equations. It doesn't matter which one. I'll plug it into equation 1. So equation 1, negative 4 equals ab to the 4th plus k. Plug in a b value of 2 and a of 1/8. So we get negative 4 equals 1/8 times 2 to the 4th plus some k value that I don't know. So 2 to the 4th is 16. That's 16 over 8 plus k. 16 divided by 8 is 2. So I have negative 4 equals positive 2 plus k. Subtract the 2 over, negative 6 equals k. So I have my a, b, and k. And all we do is plug it back in. So f of x will equal my a value of 1/8 times my base of 2 raised to the x, all minus 6. So it is a lot of work, but that's how you solve that problem. Make your 3 equations, plug them in, or reduce them down to get rid of one of the variables. That's the whole point of elimination substitution. Get rid of a variable, you keep going down until you're only left with one variable left. So get the 3 equations. I subtracted them to get rid of the k's. I factored them out to make it a little easier when we divide them. And then I divided 4 and 5 or 5 and 4 or whatever. It doesn't really matter which way. And that gets rid of the a's. And I'm left with just a b squared equals 4 or b equals 2. And then you start kind of back substituting. Take the b, plug it into one of the previous equations. You get your a, plug both of those into the first set of equations. And that's how you solve number 34. Which is kind of a big problem. Any questions here? Are we okay? All right. If not, let's keep going. All right, number 37, just a simple graphing problem. So I have 2 minus 1/3 x plus 4. So from here, you can just, when you want to graph it, just pick any 2 points that make it easy to graph. In this case, I'll use -4. And since 1/3 makes a decay, I'm also going to use -5. So when I have f of -4, I get 2 minus 1/3 to the -4 plus 4, which is 0. So -4 plus 4. So that makes this 1/3 to the 0 power, which is just 1. Anything raised to the 0 power other than 0 is just 1. So what I'm saying here is that when x is -4, my y is 1. So I have a point -4, +1. Then when x is -5, f of -5 will give me 2 minus 1/3 to -5 plus 4. Well, that makes it a -1. So I have -2 minus 1/3 to -1. And that's why I chose the point -5, because I saw that's a decay function. So when your x value is -1, all I do is just flip the exponent. So 1/3 just becomes 3. So I have -1. So when x is -5, I have the y value of -1. Stay consistent with the color. So -1. And then I have an asymptote of my k value, which is at 2. So I can go ahead and make my asymptote. Put your arrow so you don't get points off for that. And then since it's a decay function, that means I start away from the asymptote and I kind of decay into the asymptote. So it looks something like this. Domain, all real numbers. Range, I can see I start from -infinity up to +2, and they both get parentheses. Any questions about that? Does that make sense? All right, let's keep going. 38, another graphing problem. This one's a little easier because x is just 0. So in this case, I can just use x values of 0 or -1 and 0. -1 because again it's a decay function. So when x is -1, I have 1/2 to -1 minus 3. That's 2 minus 3, which is -1. So the point -1, -1. And then when x is 0, I have 1/2 to the 0 power. That's just 1 minus 3, which is -2. So when x is 0, I have the point -2 because anything raised to the 0 power is always 1. So I have the 2 points. with -1, and 0, -2. And then I have an asymptote of -3. That's right here. Put your arrows so you don't get points off for that. And then it's a decay function, so I start away from the asymptote and I decay into it. And you kind of see that with these points anyway, that's getting closer to the asymptote as x increases. So, whoops, went a little too far there. But anyway, you get a graph that looks like this. Domain, like always, is all real numbers. Range, I'm going from -3 up to infinity. You can never equal infinity, and you don't ever equal -3. So they both get parentheses, not brackets. Any questions here? Are we good? Okay, let's keep going. Now I can't even talk right now. We're jumping up to 48. So 48, that's we're gonna start with our basis of ease. So I'm told to write an exponential function that passes through the points 3, 1, 1, 2 minus 1 to the e 1 squared, and 4, 2 minus e. So they give me 3 points, but you don't really need 3 points. Honestly, you only ever need 1. But you could use 2. So here, these 2 points right here, they actually tell me what my a and my k are going to be. So the number that's being added or subtracted to the e value, in this case, is both these 2's. That's my k. So in this case, k is 2. And then the number you're multiplying e with, in this case, it's -1. You can see that on both of these. That's your a value. A is -1. So I have my k and my a right away. So I want this thing in the form f of x equals a times e to the x minus h plus k. I have my a and my k. I can just plug in 3, 1 into the equation to solve for your h value. So for the h value, when a is 1, or sorry, when y is 1, we get 1 equals my a value of -1 times e raised to the x, which we're saying is 3, minus h, which I don't know, plus my k value of 2. From here, I'm just going to solve for h, so I can subtract 2 on both sides. -1 equals -1 times e to the 3 minus h. Divide both sides by -1. We get 1 equals e to the 3 minus h. Well, 1 is the same thing as any number raised to the 0 power. So in this case, I can say e to the 0, because that does equal 1, equals e to the 3 minus h. And since these have the same base, I can set the exponents equal to each other. I can say, well, 0 equals 3 minus h, or h equals 3. So what we get is that f of x equals my a value of -1 times e to the x minus -3, or x plus 3, plus my k value of 2. So that's not too bad. Any questions about that? Are we good here? All right, and there is, like I said, there is another way to solve these with just 1 point. So let's say on the test, we only give you, let's say, just this point right here. So we don't give you these, there's still a way to solve it. So the same thing as before, this is still your k and this is still your a, that doesn't change. But this e to -2, or in general, I can rewrite this point as 1, 2 minus 1 times e to -2, move that to the top, or just 1, 2 minus e to -2. What this is saying is that when x is 1, I have a exponent of -2. But remember, my base is always e to the x minus h. What this is saying is that when x is 1, this value right here, I have e to the 1 minus h, that should equal e to -2. So from here, I can say, well, 1 minus h equals -2. I can add the 2 over to get 3, add the h over to get h, and you get the same exact. There's another way to solve it, and that's my point. You only ever need 1 point to solve for a, h, and k when it comes to bases of ease. Are you okay with that? Tanish, go ahead.
Oh, hang on. I'm sorry, my microphone was muted. How does like the point correspond to A and K? Like, I wasn't here when we did 13.4. Um, but like, how does the point correspond? Like, usually just X and Y.
Yeah, so how it corresponds is because let's say we give you the equation like let's actually work with this equation we got right here. F of x is so f of x in this problem was -1 or is negative e to the x minus 3 plus 2, right?
Yeah.
So in this case right here, I can see very clearly a is -1, k is 2, right? That's pretty clear because it's right in the equation.
Yeah.
Yeah. So let's say I have an xy table, and let's say x is 1. And I plug 1 into this equation, I have negative e to the 1 minus 3 plus 2. This is when x equals 1. Or negative e to negative 2 plus 2. Or I don't want a negative exponent, so I can say, what's negative 1 over e squared plus 2, right? So I have the point, this when x is 1, my y is negative 1 over e squared plus 2. This 2 is the k. We never really added into the number itself because e is, it's an irrational number. It goes on forever. You can't really add 2 to it. At the same time, this -1, you can't really multiply with anything because -1 times -1 divided by e squared, you can't really give an exact number for that because again, e is irrational. So we just leave it in this form because this is the most specific, it's the most accurate form. So this gives me the point 1 comma -1 over e squared plus 2. We never got rid of the a. That's always stayed a. And we never got rid of the k, so the k stayed there. So that's how you can tell right away what your a and k are because you never really got rid of it. It stayed there. All you ever did was really mess with the e to fix the exponent. That's all you ever do with these because we want to give you the most specific answer possible. And it's better to say -1 over e squared plus 2. And that's why you can tell right away. I don't know, does that answer your question? Does that make sense?
Yeah, it kind of makes sense. Thank you.
Sure. Okay. Any other questions about this? Ready to keep going? Okay, let's keep going. Number 53. I think this is the last problem due on the homework. How much to the right should the graph 5 times e to the 3x minus 12 minus 8 be translated so that 7, -3 is a point on the graph? So I'm given this equation, and I'm told, well, I want the point 7, -3 to be part of this equation, but to be part of it, I need to move it left or right. So how much should I move it left or right? So the first thing I always want to do is I don't want 3x minus 12. I don't want it in that form. I want it usually as b times x minus h. So I want to get rid of that 3 in front of the x. So when I factor that out, I get 5 times e to the 3 x minus 4 all minus 8. That's the first thing I'm going to do. And then after that, I'm asked how much to the right should the graph of f of x be moved. So anytime you're putting an h value, because moving it left to right is an h value, you put it inside the parentheses. So it's x minus 4 minus h, right? Because you look at this right here, the equation of h is in that equation. It's inside the parentheses, I mean, sorry. So I put the minus h in there, and that's also another reason of why you need to make sure you factor out the coefficient in front of x. And then after that, I have the points. This is y equals. I have the point -3, 7. I can plug this in to see what I get. So when y is -3, I have 5 times e raised to the 3 times my x value of 7 minus 4 minus h, all minus 8. I can add the 8 over to get a positive 5 equals 5 times e to the 3 times 7 minus 4. That's 3 minus h, divide by 5. 1 equals e to the Guess you could distribute if you want to. 9 minus 3h. Well, 1 is the same as e to the 0 power. So 0 equals 9 minus 3h. Or you can add the 3h over, divide by 3, h equals 3. So when h is 3, that means I'm going to be right by 3. Because h is positive. The h value itself will always tell you if going left or right. If it's positive, it's to the right. If it's negative, it's to the left. But in the equation, because it's minus h, that's where it looks a little weird, where it's like minus 3 in the equation really just means to the right of 3. But anyway, that's how you do that problem. All right, there you go. Any questions on this problem? Are we okay here? Are we ready to keep going? All right, so now we're going on to the interest sheet that we gave you guys on Friday. Because like we said, that will be on the test. So there were a few problems I was gonna kind of redo with you guys. Let me talk about that. All right, hope you guys have it out. We're gonna go ahead and get started. So we're gonna start with number 5 first. For number 5, we're told we're gonna continuously compound $500 at a rate of 2% for 20 years was the final amount. So continuously compounding, that is the equation A equals E to the, so not A, it's A equals P times E to the R times T. All right, the principal amount, the amount you have in your account equals the principal, or how much you initially put in, times the base of E raised to the rate times how many years you're multiplying, how many years you're holding. So in this case, I'm told that my principal amount is 500, so I know that P is 500. My rate is 2%, which is 0.02, and my time is 20 years. I'm going to be compounding this for 20 years. So my A is going to equal 500 times E to the 0.02 times 20. When you take this, you plug this into a calculator, what you end up getting is $745.91. So $745.91. Any questions about that? I think this one's pretty straightforward. All right, no questions here. The next one I want to do is number 10 on the sheet, and that's because for this one it was a little weirder because Teresa had 2 different interest rates for two different time amounts. So I wanted to kind of show you guys how to solve this one. So for Teresa, we're told she invests $400, or she invests $400 so that her money will earn 1% interest for the first 3 years and then 4% after that. If both interest rates are compounded quarterly, how much will her account be worth in 10 years? All right, and then we'll deal with John in a bit. So for Teresa, she's not compounding continuously, she's compounding quarterly. So quarterly means it's going to be compounded once every 3 months or 4 times a year. So she's using the compounding n times year thing we gave you on the sheet. So that's A equals P, the P times 1 plus R over N raised to the N times T. So for her, for the first interest rate of 3 years, 1% interest rate for 3 years, her principal is 400. Her N is going to be 4 because she's compounding quarterly, so 4 times per year. And then her rate is 1%, so 0.01, and her time is 3 years because she's doing it for 3 years. So we plug this all in for initial, for her amount that she has in her account after 3 years, and we get that A equals the principal, which is 400, times 1 plus my R rate of 0.01 divided by n, which is 4, raised to the n times t. So 4 times 3 is 12. Or this n times t, what that means is just how many times is interest accumulating. It's accumulating 12 times, 4 times per year for 3 years is total amount of 12 times she's getting paid interest. So we solve this out, and when you solve this out, you end up getting $412.17. So after her first 3 years, Teresa has $412.17 in her bank account. But then after that first 3 years, she starts gaining 4% interest in her account. So after that, it's 4% interest. So her principal amount for that 4% interest is going to be different now, because now for that 4% interest, her new principal is now 412, because that's how much you're taking interest on now. She has $412.17. That's what's going to be what you're getting interest on. Her n, well, her n is still going to be 4 because it's still compounded quarterly. And I want to know what's going to be happening, how much money's in her account after 10 years from the very beginning. So this part in green took 3 years. So this part in purple is going to be the next 7. And then her rate is now 4%, so 0.04. So we either make another equation to kind of figure out how much you'll have after the full 10 years. So how much you'll have after the full 10 years, that's going to be my new principal, or how much she has in her account after the first 3 years, times 1 plus my n of 0.04, or so my r of 0.04 divided by my n of 4 raised to the n times t, which is 28. And when you put this into the calculator and solve it out, so that's really the only way to solve it, you get 544.6. So Teresa, after 10 years, will have $544.60 in her account. Now, if we go on to John and trying to figure out how much money he has in his account, he initially invests the same amount of money. So he initially invests $400, just like Teresa. B goes into a saving account that pays 3% annual interest for the same amount of time. So it's just one time per year, he gets paid 3% interest on how much money he has in his account, and you can do that for 10 years as well. So for John, it's pretty straightforward. The amount he has in his account is going to equal the principal times 1 plus the interest rate, which is 0.03, raised to just t, which is going to be 10. So the amount he has in an account is 400 times 1.03 to the 10th power. And when you do that, you end up getting 537 and 57 cents. So it looks like John was worse off by $7.03 approximately. And that's how you kind of solve both of those. Does that make sense? Are we okay with this problem? I think the important part here is really this part with Teresa, because that's the hard part, trying to figure out the total amount she has after 10 years when she's earning 2 different interest rates from the same account. That's how you do it. Any questions, guys? The test is Tuesday. Hopefully I'll have this uploaded on YouTube if you need to rewatch it. But I'm gonna go ahead and stop the recording. If y'all have any questions, y'all can let me know.